Hey guys, I hope this review finds you well. I'm going to go through and work through each problem. Feel free, obviously, to fast forward to the parts that you want. First question, they tell us that the lines that look parallel are parallel. That means every section in between the parallel lines has to have the same ratio. Since the first section is 4 to 7, I actually know that every section is going to have a ratio of 4 to 7. So as I go through this, I'm going to use the ratio 4 to 7 to solve for various situations. So 4 over 7 is going to equal 2x plus 1 over 5. Cross multiply and solve. There's nothing I can reduce there. So that'd be 14x plus 7 is going to equal 20. So 14x equals 13. X is going to equal 13 over 14. Next situation I'm going to solve is 4 over 7 equals 5y over 13. Nothing I can reduce there. 4 times 13 would be 40 plus 12 would be 52. 7 times 5 would be 35y. Divide by 35, and I get y equals 52 divided by 35. All right, the next situation is the w. The w is actually on the parallel line, so I need to look at the entire triangle. I'm going to say w plus 3 goes over this entire side, which is 25. And the only corresponding piece we have is this 3, which would go over its side, 7. So nothing reduces there. 7w plus 21 equals 75. 7w equals 54. And so w equals 54 divided by 7. And so those would be my 3 answers to that problem. Boom, killed it. Next problem. It's like the first one, but a little bit tougher. The way I would imagine it is if you can ignore all of this, act like all of that's gone, what would you do? Well, I hope you would realize, hey, look what I can do in between parallel lines, in between parallel lines. So that's what I'm going to work on here, guys, is I know that 4 over 15 minus t has to equal 6 over 9. That has to be true. 6 over 9 is 2/3. 4 and 2 is 1/2. So reduce when you can. And I get 6 equals 15 minus t. That's a t. Sorry, it's hard to see. So that means that t has to equal 9. Boom, got it. Well, if t is 9, 15 minus 9, I know that this piece is 6. All right. Now, act like this part's not there. And we have basically the same picture from the first problem, where all of the pieces in between the parallel lines are going to have the same ratio. What is that ratio, you ask? Good question. Well, we know this section is 3 to 6. Well, what is the ratio 3 to 6? That's 1 to 2. So I know that every section is going to have a ratio of 1 to 2. So I'm going to set up all my proportions under that assumption. We have this situation. So even though there's that line there, ignore it. This entire side would be 15. So I know 7 minus w over 15 equals 1 over 2. Nothing reduces. That would be 14 minus 2w equals 15. So negative 2w equals 1. So w equals negative 1/2. Do the same thing for the 4 and the 2q plus 1. I know that 1 over 2 has to equal 4 over 2q plus 1. Nothing reduces, so 2q plus 1 has to equal 8. So 2q 7, so q equals 7 over 2. And then for the z, just like on the last problem, I know you guys are loving this, the z is actually one of the parallel lines. So we got to use the entire triangle. Z would go over this entire side, which is 15 plus 8 plus 6, which would be 29. And that is going to equal, the only corresponding piece we have is this 4 plus 6 is 10 over 9 plus 6 is 15. That's all we got. So that's our setup. That's what we're rolling with. So if I solve that, I get 10 and 15 reduced to 2/3. So I get 3z equals 2 times 29 would be 58. So z equals 58 over 3. Got it. So it's W, Q, Z. I got them all. Next one. Angle bisector proportions. Side over side equals side over side. 12 over 14 equals 10 over 2x minus 3. Reduce to 6/7. Reduce this direction to 3/5. And I get 6x minus 9 equals 35. Add the 9, I get 6x equals 44. So x equals 44 over 6, which reduces to 22 over 3. Always reduce. Next problem, they tell us AC is 12 and AD is 13. And then the entire length of DC is 20. Find CB, so I'm going to call that x. Well, if that's x and the whole thing's 20, just like imagine if this was like 7. Wouldn't you do 20 minus 7 and say this is 13? Yeah, of course you would. But it's not 7. You got to treat x like it's a number. It's 20 minus whatever x is. Not x minus 20. X is smaller than 20, guys. If you said x minus 20, that's a negative number. Do you hear me, Ryan? That's a negative number. You do 20 minus x. Big minus small. So we know it's 12 over 13 equals x over 20 minus x. That's just our angle bisector rule here, guys. I don't see anything that reduces. So 12 times 20 would be 240 minus, oh dear, 240 minus 12x would equal 13x. So 240 equals 25x. Divide both sides by 25. That would be 489. I don't know. I'm going to do it in the calculator real quick. 240 over 25 is 48/5. So that the answer to this question is 48/5. Killing it. Here we got this person. Oh, she's so happy. Sarah's 5 feet tall. Boom. She cast a shadow that's 5 feet 6 inches. 5 feet 6 inches is 5 feet plus 6 out of 12, which is 5 plus 1/2, which is 11 halves. So her shadow is 11 halves. I'm going to keep it in feet. The tree casts a shadow that is 121 feet long, and it says down here, blah, 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 blah. I know. I couldn't get it changed. Well, I could have. I just didn't. It was going to take too much work, and I didn't have time. So there we go. 121. And they want to know how tall is the tree. So our setup here is going to be height of the tree over shadow equals height of Sarah over shadow. There's some reducing we could do here, but I don't want to confuse you too much. But if we cross multiply, you'd have 11 halves x equals 500, 605. Let me make sure I don't want to get it wrong. 121 times 5, 605. How do you undo 11 halves? You multiply it by 2 over 11. So times 2 elevenths, and I get 110. So that means that the tree has to be 110 feet tall. Boom, killed it. Next question, are these triangles similar? If so, state the reason. If not, type NS for not similar. Well, the smallest, if I know all 3 sides, I know that the smallest side 4 would have to go with the smallest side 5. I know that the middlest side 6 would have to go with the middlest side 7.5. And the biggest side 8 would have to go with the biggest side 10. That's stuff that I do know. 4/5 is already reduced. I don't like that 7.5 on bottom, so that's going to be 4/5, going to stay the same. If I multiply by 2 on top and bottom, I get 12 over 15. 8 and 10 I can go ahead and reduce. That is 4/5. This 12 over 15 is also 4/5. So check mark, check mark, check mark. That is SSS. Here, small 5 over small 15 would have to equal small 7 over small 20. This reduces to 1/3. This does not reduce, so those are not similar. Parallel line situation. I just graded those GT tests, and I cannot believe how many people missed these situations. I expect much better from you guys. I know you can do this. This is the third one we've had on this worksheet. But the spaces between the parallel lines have to be proportional. So one of our setups could be x plus 2 over 9 equals 7 over 10. Remember, check the cross products. If you have the same cross products as I do, then you wrote the same thing I did, just a different way. There's nothing I can reduce here, so 10x plus 20 has to equal 63. So 10x has to equal 43. So x equals 43 over 10. To get the letter y, that's on the actual parallel line, so I have to refer to the entire triangle. 18 minus y has to go with the entire side, 19. And the only piece that corresponds to it is this 12, which would have to go with its corresponding side, 10. Well, 12 and 10 reduces to 6 and 5. I don't see anything else I can do. 5 times 18 would be 90 minus 5y would equal 60 plus 54 be 114. So negative 5y would equal 24. So y equals negative 24 over 5, which is okay. Make sure you put the negative on top. 18 minus a negative would be a positive. It's okay for x and y to be negative. It's not okay to be negative after you plug it in. Boom. Nailed it. Next problem. Does it say anything? Bad question. It is what it is, but these lines should be parallel or else we can't do anything. So 10 over 3y equals 14 over 11. I will have to go back and fix that. I'll change that for your version. So 10 over 3y equals 14 over 11. 10 and 14 reduce to 5 and 7. That's all we can do there. So 21y equals 55. So y equals 55 divided by 21. Got it. Here's the redraw situation we did in class one time together. Eek. I know you guys can do this. The two triangles share this corner. I'm going to put a single dash on this one. They share this one, double dash, which means that this angle has to match this angle. I'm going to redraw the two triangles. Here's the big one. Here's the small one. I'm going to put the angles in the same places. A 2, a 3, and a 1. A 2, a 3, and a 1. I'm going to make them face the same way. For the big triangle, the 2 is E, the 3 is B, and the 1 is C. On the small triangle, the 2 is still E, but the 1 is over here, A, and the 3 is up here, D. And then I'm going to plug in the values that we know. We know that E to B is x plus y. We know that B to C is 12. We know that E to C is 11. For the small triangle, I know that E to A is x. I know that E to D is 3. And I know that A to D is 10. So those are the corresponding parts. I drew the triangles facing the same way. I lined up all the parts. Now I can set up proportions. The only side I know the first and second shape is 12 and 10. So I know that 12 over 10 is going to equal 11 over x. This reduces to 6/5. So 6x equals 55. So x equals 55 divided by 6. Oh, they didn't even ask for y. So that's just it. We're done. If we had to get y, we could. We'd have to plug x in and then do another proportion. But they didn't ask for that. Oh, same question, different numbers, same picture it looks like even. I'm going to put a 1 dash and a 1. Again, both triangles use this angle. I'm going to call it a 2. And then the last angle would have to match the last angle, give it a 3. So I'm going to draw the two triangles facing the same way. A 2, a 3, and a 1. A 2, a 3, and a 1. There's no labels. I'm going to give it labels. A, B, C, D, and E. That helps me see what's going on. For the big triangle, A is the 2, C is the 3, and D is the 1. For the small triangle, A is still the 2, but E is the 3, and B is the 1. Label what we have. A to C is 5 plus X, C to D is Y, and A to D is 15. On the small triangle, A to E is 7, E to B is 6, and A to E is 7, I got that, sorry. E to B is 6, and A to B is 5. The only complete set we have is 15 to 5. Well, that makes it real easy, because I know that 5 times 3 is 15. So I could sit here doing proportions, or I could just multiply all 3 of these times 3. I know that Y has to equal 6 times 3, which is 18. And I know that 5 plus X has to equal 7 times 3. So I know that X has to be, this will be 21 minus 5, X has to be 16. So Y is 18 and X is 16 based on that. You can set up all the ratios you want, but if it's an easy to see scale factor like 5 times 3, 6 times 3, 7 times 3, man, that's just the way I'm going to do it. You don't have to, but that's the way I'm going to do it. Next problem, the area of a polygon, area, I like it, is 150 and its perimeter is 55. What's the area of a second similar polygon that has a perimeter of 77? So the perimeters are 55 to 77, which reduces to 5 over 7. That's called a perimeter ratio. The perimeter ratio and the similarity ratio are the same thing. So I know the similarity ratio is also 5 over 7. Both of those are linear. What do I have to do to a similarity ratio to work with area? I have to square it. The area ratio is going to be 5 over 7 squared, which is 25 over 49. So my setup's going to be 25 over 49, that's small over big, equals 150 over the new one, the one I'm looking for. Well, 25 to 150, that's 1 to 6. And that's all we can do. So 49 times 6 would be 240 plus 54, be 294. I don't want to mess up, so I'm going to make sure that's the right thing. Oop, typed in wrong. 294. Yep, that's what I got. 294 is the area of the second shape. The area of a portrait is 392 centimeters squared. What is the area of a pocket-sized version of the portrait if the similarity ratio is 7 to 2? Well, if the similarity ratio is 7 over 2, then the area ratio is 7 over 2 squared, which is 49 over 4. So I'm going to do 49 over 4, that's big over small, equals the big one over the small one. I don't know if that actually reduces. It looks like, I think it does. I think it's 8. Let me see, 392 divided by 49 looks like it's 8. It is 8. So that's 1 to 8. So X would be 32. How convenient. There we go. So the pocket-sized version will be 32 centimeters squared. Two pentagons are similar. The lengths of the sides of one pentagon are all those numbers. If the shortest side of the second pentagon is 12, what is the sum of the two biggest sides of the second pentagon? Okay, well, the smallest side is 12, has to go with the smallest side, 15. So we know that there's a similarity ratio of 12 to 15. So I want two sides. I want the two biggest. Well, the biggest ones are 36 and 22. So this would equal X over 22. And I also need to do 12 over 15 equals X over 36. So those would be the two biggest sides. And I want the sum of the two biggest sides. I can reduce 12 over 15 to 4/5. And I can do that on both of them. Fun. And that's all I can do. So 5x equals 88. So x equals 88 over 5. And I'm going to use a different letter because I already used x. I don't want to confuse myself. I'll call this one y. So that'd be 5y equals, that would be 120 plus 24 be 144. So y equals 144 over 5. But I need to add those together. So 88 plus 144 all over 5. I'm going to type it in because I don't want to go slow, but it'd be 232 over 5. Boom, nailed it, 232 over 5. Next problem, they tell us that the triangles are similar. The perimeter of triangle ABC is 126, and that's the ratio of the sides. So I know that 20x plus 15x plus 7x has to equal the total 126. So that's 42x equals 126. I don't know what that is. It looks like it's probably 3. Yeah, it's definitely 3. So that means that these side lengths are 60, 45, and 35. 60, 45, and 35. No, it doesn't. Not 35. Who said that, Ryan? Times 3 would be 21. There we go. 7 times 3, 50. Yeah, okay. Math is hard. There we go. Got it. The smallest side of DEF is 35, so 35 would correspond to 21, the smallest one. Find the length of the biggest side for both triangles. Well, we know the ratio would be 21 to 35, smallest side 21 over smallest side 35. And that would equal biggest side 60 over biggest side we don't know. And I've already used x, so I'll use a different letter. So 21 over 35 reduces to 3/5. 3 and 20 is 1 over 20. 3 and 60 is 1/20. So y would equal 100. So the biggest side of ABC is 60, and the biggest side of DEF is 100. Determine if the pair of triangles are similar. If so, state the reason and type a congruency statement. If they are not similar, select NS for both options. Okay, well, I assume on Schoology it looks better than this. But small goes with small, 5 over 10. Medium or big goes with big, 6 over 12. Those are both 1/2, and there's the angle in between. So this would be SAS. ABE. So if you go from A to B to E, that's the small side, then the medium side. So how would I do the same thing on the other one? Small side and then the medium side would be DBC. So SAS and DBC. It's kind of cut off, but 90 and 20, the other angle would have to be 70. 90 and 65, well, that's not it because the other one would have to be 25. So not similar, not similar. Those angles do not match. Here we have 4 with 5, small with small. 7 with 6. Oh, that's already bad. It's already bad. Medium with medium, broke it. So not similar, not similar. Eyeballs. The surface area of a human eyeball is that if the similarity ratio for human eyeballs to whale eyeballs is 9 to 31, how many millimeters squared is a whale eyeball? Hint, it's over 9,000. Round your answers to the nearest thousandths. For example, blah, 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 blah. So the ratio is 9 to 31, but we have to square that. That would be 81 to a big number. 31 squared is 961. So that's the area ratio. So the area ratio would equal 1363 human over whale. I don't know what that's going to be, but I'm going to do 961 times 1363. Get a big old number, 1309843, and that's going to equal 81x. So divide by 81, and I get 160. No, I don't. I get 16170.901. Boom, nailed it. That's it. Hey guys, I hope you had a good time. I hope that when I come back that you're all happy and that, oh, it's supposed to be Mickey Mouse, and that I had a good time. I bet I did. I know I did. I'm having a good time right now. I don't know what you guys are doing. Oh, yeah, you're doing the test review. But I'm at Disney World. That's supposed to be Mickey Mouse. He's smiling at you. I'm smiling at you. Can't wait to see you all again.